So let's look at a problem. So given the reaction SiO2 plus HF gives us SiF4 plus H2O. First thing we need to do is balance this equation. So when we go through and we balance it, you see we have one Si and one Si, so we're good. We have one H and we have two H's here, so we need at least two H's there. But then we have two O's here and we have one O here, so I need two there, which is going to change this to 4, which then gives me 4 F's, and I have 4 F's. So now I have a balanced equation, and I can start my stoichiometry problems. So you can see we have two numbers here that are given. I've got 2 moles of HF, and I have 4.5 moles of SiO2. So if we have two givens, there's a good chance they could be a limiting reactant problem, which of course these are, because this is what we're talking about. But what you could do to help yourself determine whether this is really a limiting reactant problem is to use this equation. A rule, or a trick I should say, I like to use is to write what they give me under or above, wherever you have room, your reaction. So in this case I have 2 moles and I have 4.5 moles here. Since both of my givens were for my reactants, I'm probably doing a limiting reactant problem. So then all I need to do is pick a product. In this case, I'm going to say, or pick SiF4. Reason I'm going to pick this one is because its coefficient is 1, so it's going to be easy to work with and less math in my problems. So what we're going to do is we're going to start with both of these. So first one, 2 moles of HF. Then I'm going to times my line. Remember, I want to get rid of this, so it's going to go on bottom. So I'm going to have moles of HF on bottom. I'm going to change to this product which I designated earlier. So I'm going to change to moles of SiF4. And then I'm going to be done. So I've changed into my product, just a simple mole to mole stoichiometry problem. Don't really need to go any further when you're finding limiting reactants. So moles of HF, I have 4. Moles of SiF4, I have 1. Then I'm going to work with the second one. So then I have 4.5 moles of SiO2 times my line. Remember, getting rid of SiO2 goes on bottom. So moles of SiO2, changing it to moles of SiF4 on top. Again, must keep the two products the same that I'm changing to. These have to be the same in order to make this comparison. Plugging in again my coefficients, since it's a mole ratio. So I have 1 SiO2, I have 1 SiF4. Now all I need to do is do the math. So I have 2 times 1, which is 2, divided by 4, and I get 0.5 moles of SiF4. In this one, I have 4.5 times 1 divided by 1, and I get 4.5 moles of SiF4. So now I just need to look at the numbers, and whichever one is smaller is going to be my limiting reactant. So I've got 0.5 moles of SiF4 is smaller, so that means HF is my LR, or limiting reactant. Okay, let's try another one. We're going to use this equation for our next couple of examples here. So the first thing we need to do, of course, is balance it. So I've got N2 here and I've got N2 here. looks good. I've got H here and H here, so we're going to skip the H's right now. So let's start with O's. I've got O2 and I've got 1 here, so we're going to need 2. Well, this gives me 2 times 2, which is 4 H's. But as you can see on this side, I have 4 H's plus another 2, which is 6. So I've got 4 and 6. Let's see what I can do to work with that. Could take a little math, but again, I often say if you're not sure, why don't we double it? This isn't odd, but let's still try to double it. Sometimes that helps when we go back and forth. So now I have 4 O's. So that means in front of here I need 2 more O's. That gives me then 4 plus 4, which is 8 H's. And look, I've got 8 H's. So I have a balanced equation. So again, I want to know what is the limiting reactant when I have 0.75 moles of N2H4. So 0.75 moles. And that's mixed with 0.5 moles of H2O2. So I have 0.5 moles. So again, both numbers belong to reactants, so this is definitely a limiting reactant problem, let alone it's asking me for it. So again, pick one that I want to work with. So let's work with N2, since again, it's got 1 as its coefficient. So we're going to change or start with whichever one we want. So 0.5 moles of N2H4 times your line. Putting moles of N2H4 on bottom, changing it to moles of N2 on top. Plug in your coefficients, so 1 and 1, and then do your math, and I get 0.75 moles of N2. Let's do the second one. So I got 0.5 moles of H2O2 times my line. Got moles of H2O2 on bottom, moles of N2 on top. Plugging in my coefficients, I have 1 and 2. So now I have 0.25 moles of N2. So once again, this is my smaller number. Since that's my smaller number, it means H2O2 is my limiting reactant. Now this is going to be important because we're going to use then this number again and again for any further problems. And I already hinted to you that the next 2 examples are going to come from this reaction. So we need to remember that H2O2 is going to be our limiting reactant. So the next question asks how much excess reactant remains unchanged. Well, if I want to know how much excess remains unchanged, I need to know how much I used up. So again, start with your limiting reactant. So I'm going to start with 0.5 moles of H2O2 since it is my limiting reactant. And what I need to do is I need to change it into my N2H4. Remember, I had to begin with 0.75 moles of it, but I don't use all 0.75 moles, so I have to determine how much I actually use. So if I used 0.5 moles of H2O2, I'm going to change it into moles of, H2O2, thinking ahead of myself, into moles of N2H4 to determine how much I used. Again, remember our balanced equation. So plugging in my coefficients, I have 1 mole of N2H4, I have 2 moles of H2O2, so that means I use up 0.25 moles of N2H2 or N2H4. So this is how much is used. So to know how much remains unchanged, I just start with what was given, so 0.75 moles of N2H4. So this is what was given from the previous. And I'm going to subtract my 0.25 moles of N2H4. So this is what was used up. So I just calculated how much was used. So that means I have 0.5 moles of N2H4 in excess. So that's how much I would not have used in this reaction. So how much would have been left unchanged. So for our last question, again using the same reaction, so we have to use the same coefficients. It's going to balance the same way. This time I'm looking for how much of each product in moles again. Well, nice thing is that it's already in moles. So when we first determined the limiting reactant, when we had 0.5 moles of this to begin with, and then we had X moles of this, we already determined N2. So from example 1, we know we have 0.25 moles of N2. So we just really need to figure out how many moles of H2O. So again, start with your limiting reactant, so 0.5 moles of H2O2. Sorry, it's a little late. And I need to times my line, moles of H2O2 on bottom with its coefficient. I want to change this into moles of H2O with its coefficient. And now I multiply through, so 0.5 times 4 divided by 2, and I get 1 mole of H2O. Now everything that we've done in these examples have been mole to mole. Could you go grams to moles or grams to grams? Sure, you can still do the same thing. But to get to the point where you're figuring out your limiting reactant, you can stop at moles. You never have to take it all the way to grams. Once you find out that limiting reactant, then of course you could take that further and go to grams. For example, I could change either of these and go one more step and change them into grams by doing moles of N2, changing it into grams of N2, 1 mole, and then 28 grams. Again, looking up the molar mass. Same thing here. If I wanted to change it to grams, just do moles to grams. You know moles is always 1. Grams of H2O would be 18. And then do the math and we can change it to grams. So all I've done is stopped you at moles just for simplicity of the video.